Hi, Database Management, Chapter 5, Introduction to SQL, number 2. In this chapter, we're gonna study several definition of terminologies, and then we're gonna study the history and law of SQL, and then we're gonna study define a database using the SQL data definition language. And also we're going to study writing single table queries using SQL command. And then we're going to study referential integrity using SQL. And then we will study the SQL 1999 and SQL 2016 standards. Changing table. Alter table statement allows you to change column specification. The alter command will be done after table have already been created. For example, if you have an existing database, even one with actual data in it, you can modify table by adding or changing columns, removing columns, adding constraint, etc. If data in the table violate the constraint, you will be prevented from setting these constraints until after changing the data. So, whereas create table is mostly a process that takes place during implementation, alter table often takes place during maintenance. Table action, add column under by definition. Alter column name, set default value. Example, adding a new column with a default value, alter table customer underbar T, add column, customer type, bar character 2, 10, default, commercial. Removing table. Tables will not be dropped if there are other tables that depends on them. This means that if any table has a foreign key to the table being dropped, the drop will fall. Therefore, it makes a difference in which order you drop the table. Drop table statement allows you to remove tables from your schema. Drop table, customer underbar T. Insert statement. As the rest statement, we can see add one or more rows to a table, insert into a table, insert into customer underbar T value 001, contemporary cursor 1355 South Himes Boulevard, Gainesville, Florida 32601. Inserting a record that has some null attribute requires identifying the fields that actually get data. Insert into product underbar T, product ID, product description, product finish, product standard price, values 1 and table, cherry 175, 8. Insert from another table. Insert into CA customer underbar T. Select all from customer underbar T where customer state equal CA, California. As the rest state shows, it is possible to insert data into one table based on a query from another table. We will talk more about the select statement shortly. Creating table with identity column. Inserting into a table does not require explicit customer ID entry or field list. Insert into customer table values contemporary cursor 1355 South Himes Boulevard, Gainesville, Florida 32601. Identity column were introduced with SQL 2008. There are columns whose value automatically increment with each new insert. So, an insert statement does not explicitly give a value for an identity column. This is handled automatically. Often primary keys are identity columns, but not always. Create table customer.t, customer ID integer generated always as identity. Start with 1, incremented by 1, mean value 1, maximum value 10,000. No cycle. Customer name bar character 2, 25 non-null. Customer address bar character 2, 30. Customer city bar character 2, 20. Customer state character 2. Customer postal code bar character 2, 9. Constraint customer on the bar primary key customer ID. Delete statement. Remove rows from a table. Delete certain rows. Delete from customer underbar T where customer state Hawaii. Delete all rows. Delete from customer underbar table. Remember, referential integrity rules will control whether or delete actually happen. The restrict, cascade, and send null constraint will determine how to handle the orders for a deleted customer. Rows can be deleted from a database individually or in group. Suppose Fine Valley Furniture decide that it will no longer deal with customers located in Hawaii. And then we can see previous SQL. Update statement modifies data in existing rules. Update product underbar table T set product standard price equal 775 where product ID equals 7. For this update, we know that it will affect only one record in the table. How do we know this? Because product ID is the primary key, which must be unique, so there can be only one product with product ID equal to 7. However, many times update and delete affect many records. For example, delete from customer underbar T where customer state equal Hawaii affect all customer from Hawaii. Merge statement. Make it easier to update a table It allows combination of insert and update in one statement, useful for updating master table with new data. Since SQL 2008, the SQL standard has included a new keyword merge that makes updating a table easier. Many table applications need to update master table with new data. A purchases on the T table, for example, might include rows with data about new product and rows that change the standard price of existing product. Updating product on the T can be accomplished by using insert to add the new product and update to modify standard price in an SQL 1999 DBMS. SQL 2008 compliant DBMS can accomplish the update and the insert in one step by using merge. Merge in product on the T as prod using select product ID, product description, product finish, product standard price, product line ID from purchases on the T as purch on product dot product ID equal purch dot product ID. When matched, then update prod dot product standard price equal purch dot product standard price. When not matched, then insert product ID, product description, product finish, product standard price, product line ID. Values purch dot product ID, purch dot product description, purch dot product finish, purch dot product standard price, purch dot product line ID. Schema definition. The internal schema of relational database can be controlled for processing and storage efficiency. The following are some techniques used for tuning the operational performance of the relational database internal data model. Control processing, storage efficiency, choosing to index primary and or secondary key to increase the speed of row selection, table joining, and row ordering. You can also drop indexes to increase speed of table updating. You will learn more about the selection of indexes in next chapter. So choice of indexes. Selecting file organizations for base table that match the type of processing activity on those tables. Example, keeping a table physically sorted by a frequently used reporting sort key. File organizations for base table. Selecting file organizations for indexes, feature also table appropriate to the way the indexes are used and allocating extra space for an index file so that an index can grow without having to be organized. File organizations for indexes. Clustering data so that related rows of frequently joined tables are stored close together in secondary storage to minimize retrieval time. Data clustering. Maintaining statistics about tables and their indexes so that the database management system can find the most efficient ways to perform various database operations. Statistic maintenance. Creating indexes. Indexes are created in most relational database management systems to provide rapid, random, and sequential access to base table data. Because the ISO SQL standards do not generally address performance issues, no standard syntax for creating indexes is included. Speed up random sequential access to base table data. Example, create index name underbar IDX on customer underbar T, customer name. This makes an index for the customer name field of the customer underbar T table. Select statement. Used for query on single or multiple table. Close of the select statement. Select lists the column and expression to be returned from the query. From indicate the table or views from which data will be obtained. Where indicate the condition under which a loss will be included in the result. Group by indicate categorization of result, having indicate the conditions under which a category group will be included. Order by sort the result according to specified criteria. The select statement includes many features that allows you to perform sophisticated query. You can specify the condition for rows to be included in the result, and you can choose which columns from these rows should be included. You can either get detailed data or get aggregate result such as sum and average. You also have many options in how to sort and format the result. Select example. Find product with standard price less than 275. Select product description, product standard price from product underbar T, where product standard price is less than 275 semicolon. The where clause includes one or more condition. A condition is a test that for each row in the table is either true or false. Only those with true result are permitted in the result set of the query. Comparison operation includes equal to, greater than or equal to, less than or equal to, not equal to, also not equal to. Select example using alias. Alias is an alternative column or table name. Select customer name as name, customer address from customer underbar V, where name equal home furnishings. Alias are useful. They can often save on typing time when writing a query. Select example using a function. Using the count aggregate function to find total. Select count all from order line underbar T where order ID equal to 1004 semicolon. With aggregate function, you can have single value columns included in the select clause, unless they are included in the group by clause. The most common aggregate functions are count, sum, and average. What the above query give is a number indicating the total number of order line records associated with order number 1004. Select example Boolean operator and or and not operators for customizing conditions in where clause. Select product description, product finish, product standard price from product underbar T where product description like percentage desk or product description like percentage table and product standard price greater than 300. The where clause is the query has tests for 3 conditions. It lists the product name, finish, and standard price for all desks and all table that cost more than 300 in the product table. The like operator allow you to compare string using wildcard. For example, the percentage wildcard in percentage desk indicate that all strings that have any number of characters preceding the word desk will be allowed. The AND logical operator processes before the OR operator. Figure 5-8 Boolean query without use of parentheses. By default, processing order of Boolean operator is not then and or then or. By default, the AND operation takes place before the OR, so only table over 300 are included via the AND. These are then combined with all desks no matter what price via the OR. So step 1, process AND, where product description like percentage table and standard price 3 greater than $300. Step 2, process OR, where product description like percentage desk. Step 3. Final result is the union or of these two areas. Select example Boolean operator with parentheses. This overrides the normal precedence of Boolean operator. Select product description, product finish, product standard price from product _T, where product description like percentage desk or product description like percentage table and product standard price greater than $300. With parentheses, you can override normal procedure rule. In this case, parentheses makes the all take place before the end. Step 1. Process OR, where product description like percentage desk or product description like percentage table. Step 2. AND, process AND, where result of first process AND standard price greater than $300. Sorting result with order by clause. Sort the result first by state and within a state by the customer name. Select customer name, customer city, customer state from customer table, where customer state in Florida, Texas, California, Hawaii. Order by customer state, customer name. The in operator in this example allows you to include those whose customer state value is either Florida, Texas, California, or Hawaii. It is more efficient than separate or conditions. You can order by any number of fields from the originating table. How would you have done the where clause if you used or conditions instead of the in operation? Where customer state equal Florida or customer state equal Texas or customer state equal California or customer state equal Hawaii. Categorizing result using group by clause for use with aggregate function. Scala aggregate single value return from SQL query with aggregate function. Vector aggregate multiple value return from SQL query with aggregate function via group by. Select customer state, count customer state from customer number table, group by customer state. You can use single value field with aggregate tons if they are included in the group by clause. This is an example of vector aggregate. It will return the number of customers from each state. The query will return the name and count of customers from all states that actually have customer. If all we wanted was the total number of customers across all states, we could do this Scala aggregate query. Select count all from customer on the table. This query will return a single value, which is the total number of customers. That would be the sum of all the individual numbers returned from the aggregate query displayed in this slide. Qualifying result by category using the having clause for use with group by. Select customer state, count customer state from customer table, group by customer state, having count customer state greater than 1, like a where clause, but it operates on group categories, not on individual rows. Here, only those groups with total numbers greater than 1 will be included in the final result. The having clause restricts which groups will be returned in a back to aggregate query. It's like a where clause, but operates on groups, not separately. A query with both where and having. Select product finish, average product standard price from product_t, where product finish in cherry, natural ash, natural maple, white ash, group by product finish, having average product standard price is less than $750 ordered by product finish. First, the where clause restricts us to only product with certain type of product finish. Then after that, they are grouped by the product finish and average price calculated for each group. Only the groups with average price less than $750 are included in the final result via the having clause. After all this is done, they are ordered alphabetically by product finish. So the where clause operated to restrict the number of rows, and then having clause was used to restrict the number of groups. Figure 5-10, SQL statement processing order. Select all distinct column, list from table underbar list, where conditional expression, group by column list, having conditional expression, order by column list. The select clause specify which column to return. The from clause specify which tables these come from. The where clause specifies conditions that determine whether a row is returned in the result. Group by and having are used for aggregate queries, and order by determines sorting. Query can also include subqueries, so you may see a select inside another select.